you can all hear me fine and see the slides I'm going to go through today on the webinar. Today we're going to be talking about the latest release of Fred, version 21.42, which launched just last week, I believe, if I remember rightly. A week seems a long time. And we're going to take a look at some of the new features that are in this particular version of Fred. So what's new? Well, there's been a huge update to FREDmpc. Lots and lots of work have gone on there that we'll talk about. There's also brand new support for up to 127 CPUs, so you can distribute calculations over more threads, unlimited RAM, various other things that we'll talk about, improvements to licenses, Sing and preferences. And also there's been around 40 minor bug fixes as well. Now, I appreciate that some of you on this webinar will not have access to FREDmpc, which is going to be the main topic. For those of you that are interested, you can, of course, ask us for a free temporary upgrade to get you a copy of MPC to actually test and see whether it's suitable for the actual applications that you have. So for anybody who's not aware of FREDmpc or what it is, it was launched in 2018. MPC itself stands for Massively Parallel Computing. And what's unique about Fred's method here is that Fred supports a number of different surfaces, and for those surfaces, Fred's GPU calculations work on the underlying smooth mathematical surface, not some tessellated mesh that actually approximates that surface. So that's one thing that's unique. The other nice thing about how Fred approaches this is that the MPC license is a single price, and that includes support for an unlimited number of GPUs. So if you're fortunate enough to have a large desktop or server that has several GPU cards in there, then actually Fred will automatically split our calculations over all of those cards. And what's more, if you have several PCs, each with one or more graphics cards, then it's actually possible to split calculations over multiple PCs and multiple cards. So the MPC updates, before I kind of talk through this slide, I'm just going to switch into Fred here. This is the former version of Fred, and I'm going to kick a calculation off because we're going to talk about the actual ray trace speed. So I'll kind of let that go in the background whilst I'm talking here. So the big thing that's happened in the last 16 months or so is that there's been a complete rewrite of the GPU ray trace code, and that's obviously taken a lot of effort. It's why there's been a longer gap than normal between updates to Fred. But one of the biggest benefits we get from that is the speed gains. So what we've seen in testing is that MPC ray traces in the single precision mode are around 2.5 times faster than they were in the prior version of Fred. There's a bit of a bracket on that. This chart on the right-hand side shows this, but essentially we see an average speed up of a factor of around 2.5, but the speed up can go as high as just over 4 times faster. So that's a great thing to actually have. But as this chart also shows, the other really big change we have in the latest version of Fred is we also now support double precision calculations. We'll talk about double precision in a bit more detail in a moment, but essentially this new type of calculation allows us to solve problems that typically were challenging for the single precision trace. There is a speed penalty for running a trace in the double precision mode, so it is slower than single. However, it's still typically about 1.2 times faster than the single precision calculation in the prior version of Fred. So when we think about how double precision relates to single precision of the prior version of Fred, there's almost no speed penalty whatsoever. I should point out that this was using an RTX 2060 graphics card, which is a mid-level prior generation GPU. So if I just flick back to Fred here, you'll see in the prior version of Fred, we have a lawn lamp type system. This is tracing around 63 million rays. In the prior version of Fred, this took 35 seconds. If I close this now and kind of move to the latest version of Fred and run the same trace, it runs a lot faster. So we're actually generating here around 1 million rays per line. And each of those million rays is actually executing in about just under 0.4 of a second per million rays traced. So this is already over halfway through and will finish in a moment. But the speed gains that we're seeing are even on mid-range boards is incredibly good. So in this case, 27 seconds, which is obviously faster than the 40 seconds prior, which is, a great speed up benefit to actually have. Obviously, the GPU hardware you have has an impact here. The speed increase that you see will be dependent upon the actual GPU that you have. Better cards with newer architectures have an improved performance for the double precision operations. This newest version of MPC requires you to have a card with an NVIDIA compute capability of 6 or higher. So for those of you that keep track of these things in terms of architecture names, that means you need some Pascal boards or better. It's also, of course, necessary to have the latest drivers, so we recommend to update those to version 512 there. So double precision is one of the big things that were added, and what does this essentially enable us to do? Well, double precision enables us to ray trace a optical system with larger differences in the intersectional length scales. So, what do I mean by that? Well, if I flip over here back to Fred and take a look at this other file, this is a fairly simple file here. If I just show you what's going on, if I turn off this source and turn on this one and just trace and render it, I have a source ray that starts here, goes forward, hits a mirror that's currently very close to my lens. Then it goes back through this optic, which is a doublet lens with a very small air gap. So if I zoom in here, you can see the ray deviate through that air gap, and then it's impinging on this surface at the back here. So what we have is a fairly simple test where we just run a script, and the script moves this mirror away in segments. So the largest scale will be the air gap between the lens and the mirror, and the smallest intersection scale will be this little air gap here. So if I just run that script for you now, see the mirror moving away. It's going to go further and further and further away. It's moving by a factor of 10 every single time. So Z location becomes large. What we can see in what's being printed to the output window here is in the first data column is the Y height of this ray measured on this plane using the CPU. So this is a consistent calculation. The CPU is the gold standard in terms of accuracy. It always has been and likely always will be. Then what you see is the ray height calculated via the single precision trace and via the double precision trace. And you can see that the single precision trace gives you nice accurate numbers up until a length scale difference of about 10 to the 5. And then the calculation breaks down, and single precision calculations just can't get us the right answer anymore when the length scales are so vastly different. But with double precision, we get the right answer all the way pretty much out to this length scale of 10 to the 9, okay, which is essentially what this graph highlights here. So what this means is if you have a length scale where the smallest feature size is about 100 microns, then with single precision, the largest length scale could be around 10 meters. But if you run the actual ray trace in double precision mode, then you can go from 100 microns at the smallest scale out to 100 kilometers at the largest scale. That's quite a big difference there that double precision gives us. Where do we turn this on and off within the software? There's multiple places. In the new version of Fred, MPC gets its own toolbar and its own menu. So in the toolbar, there's a highlighted button here that I can kind of show you. And also in the menu at the top level, under the MPC tab, which is new, there's an option in there to set the ray trace to double precision. And also, if we take a look at the MPC Advanced Trace, then we can also see that there is now a checkbox in here that allows us to turn this on also. So those are the three places that you can turn this on. In MPC, there's also some additional things though. So one of the other really nice things that's been added is that the actual ray trace that's done on the GPU can now access the child ray data, so rays that split and scatter and do all these wonderful things. And we can apply ray filters to those child rays and filter rays directly on the graphics card as the calculation is done. So again, if I just go back to Fred here and back to my lawn lamp, this was the analysis done from the first run. You can see that the light extends all the way out to the edge here. If I open this out, so the light goes all the way to the edges. In the new version of Fred, I can also go to my detector entity and I can edit my filter in here and potentially say, well, let's only include rays that are a certain radial distance. Let's say, I don't know, 28. And apply that filter. And if I redo my trace now, let's go single precision mode, sorry. So the prior calculation of 22 seconds was a double precision calculation. So this is now single precision with filtering. And this is going quite a lot faster, about 0.2 of a second per million rays. And that's 17 seconds, right? So again, faster still. But now we've had the filtering. If I open up my detector entity here, I can see that the rays have been filtered. Other things that are now within the software are, because the GPU calculation gives us the child rays, we can also return ray count data that previously wasn't possible to do on the GPU either. So if I just go back to my file here, let's just improve this by actually applying the filter to the right surface. There we go. Let's do that again. Again, this is going to take around 20 seconds to trace rays with the filtering based on the right surface on the actual detector. So 55 million rays, nearly up to the 63 million and done. There it is. And now if I take a look at this result, okay, well, the filtering still looks about the same actually. The child ray data is available for us, and we can see that if we go to the right click option in here and choose the detailed report, you can see that the ray count is actually returned in this data as well. So that's a new feature. And also MPC will now support diffractive surfaces. So for those of you that want to design a spectrometer and need lots of rays calculated, Fred can now handle that type of thing. And also ideal lenses are also supported with MPC. So the other things that are new in the software is support for up to 127 threads or cores. That's in both Fred Optimum and MPC. This is a screenshot here taken from when we tested this on an X1 x 32 large box from AWS. They cost around $20 an hour, which is incredible. And for that $20 an hour, you can split your calculations over 127 threads, which is incredible to see. And also the maximum ray buffer size has been delimited. So it now supports as much RAM as there is available on that machine. And this is a screenshot from the same Amazon Web Services box that has about 2 terabytes of RAM. And that RAM here is used to show around 8 billion rays being able to be held in the Fred ray buffer before anything starts paging out to disk. Other things that are very nice that have been added is a new color chart style called Turbo. And Turbo is very good at rendering out levels of detail. So this middle graphic here shows you a cross section of an irradiance plot, which is this just very linear shape. In the prior version of Fred, that would be rendered in false color looking like this, and it's very difficult to see how the levels change within this green zone here and whatnot. When you use the new turbo color scheme, it's very easy to see how the levels are actually changing. So it really renders out that detail in a very nice way. And other new items that have been added are support for ray buffer compression. So this is a part of the Advanced Ray Trace dialog box. If I just flip over to it here. So from Advanced Ray Trace, once you've applied filters and you perhaps want to remove data of rays that meet some criteria, you can also check this box, which will compress the size of the ray buffer down to get rid of all of those slots within memory that we no longer need. And then any subsequent operations on that ray buffer become a lot faster because of its smaller size. The CAD export now supports an option to export selected entities. So that is available. We've also increased the number of pixels that can be rendered for detect entities in the 3D view. So when you have some data in here and you want to display it in your visualization view, and that's hide our detector, this is now can be rendered with a lot more pixels and be a lot smoother. And then there are other things under the hood, which won't make so much difference to users that have been using the software for perhaps a long time, but for new customers, it probably makes a bigger difference. So things like preference settings to actually default to some settings to increase speed of the rendering and whatnot. And also on the licensing side, there's been some changes to make Fred a little smoother for folks that have bought the newer Sentinel type license keys, and to give more detail in the case of any licensing problems so we can troubleshoot them faster, although licensing problems are incredibly rare. So where are things going? The intention for the next version of Fred is to look at the following areas. So we can't promise any of these things are guaranteed to be in the next version. It's just things that we are looking at, and hopefully these things will kind of excite you for future versions of Fred. But of course, the MPC version of Fred will continue to increase its capabilities. And one thing that's being looked at is being able to actually support polarization in terms of calculations. We're looking at updates to CAD import and export with the possibility of then supporting more formats, additional volume scatter options as well. And then there's also projects looking at work to improve the 3D viewer in terms of making it render things a little better than it currently does, and also making it more kind of responsive. And then there's also a potential to add some additional freeform services that people are asking for. So we are aware that there was a fairly significant gap between version 20.01 and version 21.42. That gap was not considered normal. Obviously, there's a lot of work going on in the background. Photon Engineering are actually working towards getting a new version of Fred out again towards the end of this year. Okay, so hopefully there will be 2 updates to Fred in 2022. That is currently the plan. And of course, we welcome your feedback on what you would like to see in Fred. So for those of you that have any ideas in terms of what you would like to see, please get in touch with us and let us know, and we're happy to pass those ideas on and try to get them on the development roadmap. So in summary, there's been a complete rewrite of Fred MPC, and that's expected to enable further updates. Support for 127 CPUs and much more RAM. New preference settings to turbo color scheme, improvements to licensing, and around 40 minor bug fixes. We're not going to spend any time looking at those. They are all in the release notes of Fred. For those of you that aren't aware where to find them, you can go to the help and then release notes, okay? And all of the detail is in there. And again, for those of you that don't have MPC but are interested to give it a try, please get in touch with us and ask us to get you set up with a temporary license so you can give it some tests. Further information can be found on the website. And then Photon Engineering also have a number of wonderful articles on their website, which are well worth a look to. Have a great rest of day. Hopefully you'll enjoy using this latest version, and I hope to see a number of you